This is part two of the Accelerator Workshop SQL series. So my name is Thad, and I'll be doing today's workshop. If you haven't already, I just want to reiterate, please use the QR code right on this slide to check in. I also want to announce that for those of you that are interested in real points, they'll be at the end of the workshop. So please stick around. Um, so as we go through this, I just want to mention that feel free to type in the chat any questions that you do have. We have a bunch of people that are monitoring chat as well as myself. So if you have any questions, just drop it as soon as you have them, and I'll be able to answer them throughout the workshop. So, okay. Before we get into anything, I want to make sure that we know our basics. So we went over last week quite a lot of things. There are a lot of concepts in SQL that are really important to take note of, but here is a generalized list of the most important concepts that were discussed. So I'm going to just ask you guys a few quick questions, just to kind of get you guys thinking and to just have a little bit of participation on your end. So let's assume that this table on the right-hand side is called, I don't know, let's call it sales. So can anyone give me a SQL select query for fetching all rows with a rank less than 10? So what we're doing here is creating a select statement in SQL. And like I said, our condition is going to be having a rank of less than 10. So if you look at this picture right here, we have like ranks 1 through 10 and all these rows for like different video games. So can any of you guys just type in the chat a SQL statement for doing exactly that? And I'll give you guys just a few seconds to type up your SQL code. Okay, doesn't look like anyone wants to give it a shot. That's okay. Oh, actually, we do have one. So select rank less than 10. That is pretty close. Yeah, so if you were to combine what Bhakti said with what Mariam said, we would have select star or all from sales, and then we use a keyword of where. So select star from sales where rank is less than 10. So awesome. The next thing that we have is insert statements. So it's exactly what it says. It allows us to, in SQL, add new columns into our database and give it a rank, a name, a platform, essentially corresponding to these columns right here. So we're able to add new data into our database by using an insert statement. Next, we have our foreign keys. So foreign keys are kind of ways for us to connect two tables together. So I can refer one object in another table using things like foreign keys, which allow us to uniquely identify entries. And then next is going to be joins. So joins were another like pretty big concept from last week. They essentially allow us to combine and aggregate our data accordingly. So if we were to have kind of like a Venn diagram, picturing it in your head, where like we have like a circle of A and a circle of B, we could do joins that intersect or like are the union or intersection of both of those data sets. So if you did attend last week, like Intro to SQL workshop, that should kind of just be like a recap and kind of just refreshing your mind on what exactly we did. But if you didn't, that's completely okay. So for the purpose of this workshop is going to be, if you recall from the description, going to be working with large data sets and making sure that you are as efficient as possible when you're working with such large quantities. So because this is a very concept-driven idea and not so much about actual SQL, we're going to keep the syntax to a minimum, and we're going to only be working with select statements. So that should kind of ease up a little bit of like the technicality. So we're just going to be focusing on that concept of large data sets. All right. Okay, so the overview for this workshop. The first thing that we're going to be doing is discussing this Python package called psychopg2. So we're going to be using PostgreSQL. This is the database that we used last week. So I just want to stay consistent and be able to utilize exactly what we worked on last week so that, people aren't getting confused and whatnot. So we're going to be using this Python package that essentially hooks up PostgreSQL into your Python code. Now, there is a plethora of reasons as to why you might want to do this, and we'll go over all of those reasons shortly. Next, we're going to be going over how to actually connect to your database inside of your Python code. So being able to communicate with a database without the usage of something like PostgreSQL admin, like we did last week, where we were kind of just typing SQL code into that like workbench. Now we'll be using Python code. Next is going to be actually creating a simple reusable query. So if you recall, like these queries such as like select statements and like insert statements, we'll be able to move away from actually having to type those out constantly and instead kind of modularize it so that we're able to use this as many times as we want with relative ease. The next topic is going to be developing more complex query builders. So queries can get really, really frustrating and really long depending on what exactly you want your database to do and what your queries are going to do. So Python can help us ease a little bit of that pain. And lastly, we're going to be talking about actual automation with large data sets. So, all right, let's go through first psychopg2. So like I said earlier, this is a Python database adapter package, and it essentially allows you to write your SQL to a PostgreSQL database. And this is entirely in Python. Now, this is an amazing thing because of two key concepts. The first is going to be abstraction. So what abstraction actually means is just taking a complex concept and then kind of dumbing it down into like more easier to learn concepts. So with SQL, you have like a bunch of different complex things that's going on inside of your queries. So in order to do abstraction, you take those like SQL commands and you write them only once, and then you can just wrap that inside of Python, and you'll be able to use that Python code instead of having that complex SQL code. So we'll kind of like take a look as to what that really means in our demo. But the next thing is organizational design. So in Python, you're able to kind of like create functions that are essentially containers of different functionality code. So when you have a bunch of different functions, you're able to like pick exactly what you need and then be able to run that inside of a function by just using one call. So it allows you to containerize certain pieces of logic so that you don't have to rewrite it all the time as you would in SQL. And abstraction, again, can do complex query building. So it can create increasingly long queries and then shorten them by like an exponential amount, just because you're able to use Python to do computation rather than having SQL commands after SQL commands. The other concept is going to be automation. Now, this is really important because Python is kind of like the king of automation. There's like a really popular book called Automate the Boring Stuff with Python. And if your YouTube feed is looking anything like mine, you'll probably see like 1,000 automation projects that you could do with Python. A lot of people love using Python for automation. And for data analysis and for working with business logic, this is no exception. When you're working with increasingly large data sets, it's really important to be efficient in your day-to-day work because there's only so many hours in a workday. You don't want to spend like 4 or 5 hours rewriting and reusing a bunch of SQL code when you could just use Python to wrap all of it and be able to rerun it as many times as you want. So Python allows you to kind of just skip all that typing steps and just focus on the actual concepts that you want to achieve. So inside of psychopg2, the first thing that you need to do is actually connect to your database. So you need four things. The first being the host, whether it is a local host like on your local PC, or if it is on the cloud like AWS, things like that. You also need the database name, the username, and the password. So if you already have like PostgreSQL installed, um, these might be a little bit different. That's just because of the way that you actually set it up. So for this workshop, my username is just going to be Postgres and the password is going to be admin, and you'll see that in the code. But it could just be a little bit different if you were to be following along. So once you actually connect to the database, you're able to do database operations. And this is exactly the type of operations that you would do in SQL, like in regular SQL. So being able to create tables, fetch queries, insert and update queries. We won't be going over like inserting and updating. Like I said, I'm just going to keep it a little bit simple with just select statements. But if you were to be doing insert and update queries, you would be able to essentially change exactly how the database is. And all you would have to do is commit those changes to the database, kind of like, saving your changes like in a Google Doc. Okay, so about queries, well, what exactly like are they inside of like this PsychoPG2 environment? They're essentially just Python strings. So you oftentimes just use formatted strings, and if you don't really know what that is, we can get into that during the demo. But whenever you want to run a query, it's as simple as just typing up your queries in SQL inside of a string. So it follows the exact same syntax as like regular SQL commands does. And this allows you to, like I said before, abstract SQL into Python code. And due to the use of formatted strings, you're able to integrate Python variables into queries. So this allows for like really, really seamless query building in analysis programs. And we'll get over, we'll go over exactly what that means towards the very end of this workshop, because that's kind of like the exciting part. Okay, so enough chit chat. I think the most important thing is going to be demo time. It's pretty difficult to talk about this, like, abstractly. So we're going to go jump right into VS Code. So can everyone see my VS Code? I just want to verify that it's screen sharing and not screen program or program sharing. Yes.
Yeah, we can see it.
Okay, cool. So the first thing we need to do is actually install PsychoPG2. I already have it installed, but for those of you that don't, if you are following along, it's just a Python package, and you would install it like any other Python package. So it would just be pip install psychopg2. So this will install the module to it. Like I said, it's already downloaded. So for me, the requirement is already satisfied. So I'm just going to clear that. But okay. The first thing that I'm going to do is now import it into my coding environment. So it's just as simple as doing an import statement. And that's it. To verify that it works, I could just save this and run my Python main.py. And you'll see that it doesn't output anything because I'm not really doing anything. But it doesn't throw any errors, which means that it installs successfully. If I like were trying to import something that didn't exist, like psychopgy, it would throw like a module not found error, but it doesn't do that. So we are good to go. Okay, so the next thing that we need to do is, like I said in the slides, connect to an existing database, to a database. Now, what I said previously about this package is it is incredibly simple. So what we can do is just connect to a database doing psychopg2.connect. And the things that we need in order to actually connect to a database are going to be the database name, the username, and the password. So in order to pass that in, it's just a string. So db name is the parameter. And we're going to be using my database called VG Sales. And we're going to also use my username and password, which is, like I said before, Postgres and admin. So this function actually returns a connection object. So we're going to want to store that inside of a connection object, or we could just call it con. And the next thing that we're going to want to do is open up a cursor. Now, what does that really mean? Just kind of like keep that in the back of your head as to what that really means. I'm going to go over now what the database is. So I'm going to open up my admin. And if you see, like, this is my Postgres admin, and this is the database that we're using. Or sorry, this is the table that we're using. This table is called sales, and it's inside of the database called VG sales. VG stands for video games. And you'll see that this database contains quite a few things. It contains the rank, name, platform, year, genre, blah, blah, blah. And like looking through all the way down, I think there's like over 16,000 or something. So it's quite a large data set, right? Exactly what we need. But yeah, this data set is containing a bunch of different video game information, okay? So what a cursor does, like I said, when we're opening up a cursor is, actually going back to this, a cursor is essentially like what my mouse cursor is doing right now. It's kind of like going through all the database information. So if I were to say like, hey, cursor, can you like select everything from sales? So like select star from sales. The cursor is the thing that's actually moving around the database and doing that for me. So a cursor you can kind of think of as the thing that is doing all the work. And the con or the connection is just that. It's just a connection. So we want to create a cursor from that connection. And in order to do that, you would just do con.cursor. Again, super intuitive. And the only other thing that we need to do is to make sure to close communication when we're done with it. So I'm just going to do that before I forget. I would just do cur.close. So I would first want to close the cursor, and then I would want to close the connection. So now anywhere in between opening the cursor and closing the cursor is going to be my SQL stuff. Okay. So now that we have all the preliminary stuff out of the way, I'm going to kind of set the scene here. Okay, let's pretend that I'm a data analyst for an aspiring video game development company. My entire work revolves around doing market research on global video game sales in order to make marketing decisions to maximize the total number of sales for our video games, right? So essentially what I'm doing is my job is giving me this database of top video game sales of all time. And they're asking me to do analysis in order to justify business decisions for marketing purposes. So our data set looks, I'm going to go over this again. It looks kind of like this, with all of our video games of all time. And it gives us regional sales. So NA, EU, Japan, other sales, and global sales. So the company has given me the task of doing continuous analysis on this data set. So I'm doing like market research and trying to figure out what the best marketing approach is so that we can maximize profits. After a few weeks, though, I start to realize that my SQL queries are becoming like increasingly similar. Like day in and day out, I'm writing kind of like the same 7 or 8 different SQL queries. And that takes a lot of time sometimes, especially like when you have to rethink what your conditions want to be exactly. So I realize that my like SQL queries are becoming really similar, and I want to find a way to make it a lot more efficient. I'm also kind of realizing that SQL lacks the analytical tools that Python provides. So you kind of want to find a way to like handle data fetching in SQL and data analysis in Python. So that exactly is where PsychoPG2 comes in. That's why we want to integrate SQL into Python. Okay, so now I'm in the process of understanding that SQL just isn't cutting it. So I kind of want to migrate my stuff into Python, but still using SQL to interact with my database. So the first thing I'm going to do then is test that this concept actually works, integrating SQL into Python. Okay, so in here, I'm just going to execute a command. Command to select all rows where, let's see, just to test that it's working, I'm going to select everything where like the platform is we. Platform of game is we. Okay, cool. Now pop quiz coming up shortly. But in order to execute a command, it is really simple. Like I said before, the cursor is the thing that's doing all of our work. So in order to execute a command, it's just cur.execute. That's a lowercase, execute. Cool. So inside of here, if you remember from the slides, all of our queries are going to be string based. So in here is going to be our query. So query here. Now, pop quiz. Can anybody tell me or type in the chat a properly defined query where I select all of the rows where the platform of the game is we? You guys can type it in the chat and we'll try it out. So yeah, like I said, everything in this workshop is kind of just going to be select based because it's quite simple. But I do just want like a little bit of participation on you guys' end. So if anyone could write that SQL command, that would be awesome. So to reiterate, select all the rows where platform of the game is we. And the table name is equal to sales. So does anybody have any ideas? Yes, Adrian. That is exactly right. So I'm actually just going to copy from chat and then put it here. Okay, cool. So there's a reason why I'm using double quotes here. And that's because when you're referring to a string inside of SQL, you're using these single quotes. So in order to differentiate between single quotes and double quotes, I just use double quotes to be safe. But yeah, Adrian, that's exactly right. So I'm going to execute this now, save it, and then run python.main, and you'll see that nothing is being run right here. And the reason why is because, well, we're not actually printing anything out. In order for us to get the data that we want from this executed query, we have to fetch all of that data. So we can do something like results is equal to cur.fetchAll. So this just gives us every single output from this query. And after that, we just print results. So let's just save that and run it. And you'll see that it is printing for a really long time. And I'm just going to stop that, like clear this. And to make it a little bit more pretty, I'm just going to like install another package called Pretty Print. This just allows us to look at things a little bit more clearly when we're printing things out. So you don't need to do this like ever, but I kind of just want to, just because for demonstrational purposes, it really helps. So I'm going to create a pretty printer, and then instead of just regular printing, I'll do a pp.pprint. And when I run that now, you'll see that it is a lot more formatted. So let's test to see that it actually is working. If we look through all of the items in here, you'll see that there's we here, we. So everything seems to be a platform we game. So it looks like it's working just fine. So good job, Adrian. Okay. So now we have kind of like, we're kind of like in a weird spot now. You may be wondering, well, what is the point of even doing this in Python in the first place? Like I just wrote 22 lines of code to write something that would have taken only one line of code inside of SQL. And you're absolutely right if you are thinking that, but we will be able to see the benefits in just a second. So let's first create our like our first complex query builder. And what I mean by that is let's try to create like a select query builder where we can have a bunch of different conditions. So in order to do that, let's first create a function. So right up here, we can define a function called like select. Okay. So this is the function that allows us to select whatever we might want inside of our table. So this is going to need our connection, or sorry, our cursor. And for right now, if there are no conditions, let's just say that I want to just select everything. All right. So base query is going to be select all from sales. And for right now, we could just do like, we could just execute it. So this, and then I'll just copy this stuff. Okay, cool. So this function as of right now is literally just doing what I did over here, except instead of limiting it to just the platform of we, I'm just grabbing everything. So let me just try that right now. I can just do select cur, passing in that cursor object, running this. So I'm going to clear and rerun my Python. Okay, so you'll see that it is constantly returning everything. So Control C, you'll see that this is from the Xbox One, PS2, Xbox 360. So it's literally just selecting everything, which it should do. However, that's not the only functionality that I want this to have. I want it to be able to grab either everything or things only according to my conditions. So in order to do that, I can create a conditions parameter, and I can have that be an empty array. So as of right now, I have no conditions. So if I don't have any conditions, I want to just select everything. Okay. So in order for me to do that, I could say something like if the length of my conditions is equal to 0, which is another way of saying if I have no conditions inside of this conditions array, then I could just execute my base query. So do this, and then return everything that it gives me, which is the fetch all. So cur.fetch all. Okay. So what if I have a bunch of conditions? So let's just move this down here. So what if I have something like my conditions are going to be, let's say like platform equals we, and I also have another condition of like year is greater than or equal to like 1999. And another one that says publisher equals Nintendo. So if I have multiple different conditions, the way that I say this in SQL is going to be select all from sales where, and I'll actually do this on different lines. This is the equivalent of saying select all from sales where platform equals we and year is greater than or equal to 1999 and publisher equals Nintendo. So you'll see that I'm stringing together these conditions using the and keyword. So again, because queries are built using strings, it's literally just as simple as adding together strings. So if I do have a bunch of different conditions, then I have to use the where keyword first. So in here, I'll just say at least one condition, add where keyword. So then I just do base query plus equals where, and trailing as well as appended spaces because you have to account for like the conditions afterwards. And then here, we're going to iterate through all conditions and then add conditions to our query. So in order to do that, we just do a for loop. So a for loop through all the conditions. And there's a reason why I'm using an index for loop rather than a for each loop. But we'll see that in just a second. So essentially what we want to do is add our conditions. So in this right here, we're essentially saying we have select all from sales, where, and then in here, I'm just going to be adding together our condition. So where platform equals we. The only problem is I need to add the keyword and. So let's just do that. Base query plus equals and. Okay, so now does anybody kind of see a problem with this line right here? So it's a little bit tricky, like seeing this code if you haven't been following along too well. But essentially what I'm doing here is I'm adding together this base query. So I'm saying select all from sales where, and then my first condition is going to be platform equals we. Okay, so select all from sales. Select all from sales where, and then I'm going to add this condition. And then my base query and year. So now on my second iteration, so I'm doing this again, adding my condition, and then adding the keyword and. So I'm just going to continue doing this where I'm adding the condition and then the keyword and. So does anybody see a problem with particularly line 15? And I'll give you guys a second to think on that. It is a little tricky to kind of see. So what do you mean by at the end? I'm particularly talking about like any problems with this line of code right here, like 15. Okay, so essentially what the problem is, yes, perfect. For the last condition, it would still add and. So if I were to continue to build my query right here, I would say and publisher equals Nintendo. And then it would say and then I will be done. We don't want this trailing and though, because that's a syntax error. So in order to stop this, I only want to say and if it's not the very last item. So in order to do that, I just say if I is not equal to the length of conditions minus 1, because the length of conditions minus 1 is going to be the last element. And that's why I use an index for loop. So, OK, cool. Now I'm just going to remove all of this, and we're going to test this out. The last thing that we need to do is actually execute it. So we're just going to do a cur.execute on the base query, and then return exactly what it fetches. So return multiple conditions query. Cool. OK, so inside of here, I'm going to try out first res is equal to select. We're going to pass in our cursor, and then we're not going to pass in any conditions. So we're just going to print or p.pprint for the pretty print res. OK, so I'm going to run that, and it is running everything like we want it to, which is perfect. And I'm just going to stop that. And then I'm going to try giving it a condition. So conditions equals, it has to be an array. And our condition is going to be where, let's say, platform equals we. So we save that, Python main.py, and we run this. And we'll see in just a second that everything is we. So all of these are we video games. So that works. And then we can try adding multiple conditions. So platform is equal to we, and the year is greater than or equal to 2000, I don't know, like 10. I don't know when the Wii stopped making video games, but let's hope that this works. So we can clear this and run it. OK, so this is a Wii game from 2011. This is a Wii game from 2010, Wii game from 2010. OK, so it looks like it worked. So we have successfully created a a complex query builder in which we're able to string on multiple conditions, and it is flexible enough to do exactly that, where we could just pile on different queries or conditions for our queries. Now, hopefully you guys like at home can kind of understand why this is so powerful, because let's say that we don't want to look at just the year of 2010. We can kind of like do some complex analysis. Okay, so remember, I'm a data analyst for a video game design company, right? And I want to target like at specific times. Whoops. And I want to like target at specific times. Well, what if like my year was actually like some fancy computation here, right? Like this is like a function that calculated the most optimal year for me to search for in this query. Well, instead of just hard coding it here, I could then just like create a formatted string and then in here just do like year, right? So our conditions can continue to build and we can have some really, really complex SQL queries. And all we got to do is just add it to this list of conditions. So we don't have to worry about that anymore. So this is kind of one like really good example of where automation and like ease of use in SQL can be well integrated into Python. We just wrote only about, what is that, 12 lines of code. And now we're able to create a super dynamic and foolproof and unbreakable piece of SQL code by just stringing together conditions. So an example that we're going to go over for the last bit is for this year right here. We're not actually going to be doing like optimal years, but we are going to be doing something very similar. So let's say then that I wanted to analyze what makes a game rank kind of high. So we can take like the average like Japan sales of, I don't know, like say the top 10 and find other games that have similar Japan sales. Since like Japan is like super big on video games. That's actually kind of like a marketing strategy that a lot of video game development companies do, is they specifically market towards the Japanese people, because if other countries see what like the Japanese people are playing, it kind of like has a trickle down effect, because you know any game that the Japanese are like super into, they know that it's a good game. So there have been like a lot of like studies on this where like Nintendo doesn't even like advertise in the US. They just straight up like market in Japan. And then it kind of like, you know, trickles down and a bunch of people buy it, even though they haven't even heard of it other than from the Japanese. That's like a little piece of trivia. But anyway, so we take the average Japan sales of the top 10 and find other games that have like really similar Japan sales. And then we analyze the differences between those games and the top 10 games to figure out what they did wrong so that we could apply the same strategies on our video games. So let's then create a function that allows us to find the average Japan sales. So let's go here and call it like find average Japan sales. And it's going to take our cursor. So we can do like a res equals, you know, select cur, like we've seen this before, and then our conditions. And in here, we can just say like rank is less than or equal to 10, so that we can analyze like the top 10 ranks and then find out their find Japan sales. But we don't want to hard code 10 because we kind of want to be as flexible as possible. So I'm actually going to create a default parameter of rank 10 and then create this formatted string so that I can change this whenever I want. So now when I call find average Japan sales, I can call it with just cursor, or I could call it with rank equals like 25, like top 25, okay? So now we're gonna find the Japan sales. And I'm gonna go through this a little bit quickly because this is not, you know, a Python tutorial, but essentially we're gonna go through all the Japan sales, and we're gonna loop through our results for the top 10 or top rank of things, like top, you know, 10 video games. And then we're just going to go through our database. So if you recall, Python indexes start at 0, and we want the Japan sales. So it's going to be 0, 1, 2, 3, 4, 5, 6, 7, 8. It's going to be our 8th element. And if you don't exactly know what I am referring to, let's look at this output right here. This output right here is just going to be a really big array. And we know that because of this bracket right here. So our res returns an array. And inside of those arrays are these tuples. And inside of these tuples are going to be each column of a row. So this is going to be the rank, name, platform, year, so on and so forth. So rank, name, platform, year, so on and so forth. So the 8th element is going to be our Japan sales, which is 0, 1, 2, 3, 4, 5, 6, 7, 8. So this particular video game actually has a 0.0 Japan sales. But it is going to be that 8th spot. So in order to find total Japan sales, we have to add that, so plus equals, into our results at spot I. So res at I is referring to that video game. And then spot 8 is referring to that particular video game's Japan sales. So hopefully that makes sense. And then right after this, we're going to return average Japan sales. So this is going to be total Japan sales divided by the length of the res. So length of res is going to be the same thing as rank, but this is just like a little bit more clarity as to what I'm doing. It's literally just the average formula of total divided by number of samples. So now we have average Japan sales, and we can actually test that here. So let's just say average Japan sales equals find with cursor, and then we're just going to want to print that. So, okay, let's print that. Okay. Ooh, LES. Oops. LEN. Okay, so this says 4.65. So if we look here and we go to like the top 10 and you add them all up, it actually is 4.65. So that's working, which is awesome. And now what we want to do is create a query where you want to find other video games with Japan sales greater than or equal to like the average. Okay, so oops, I actually deleted that piece of code there. So okay, so we have our average Japan sales, and now we want to find other video games with the same Japan sales. So in order to do that, again, we use our really super convenient, ease of use, select query builder. So we just do res equals select, we pass in our cursor, and then in the conditions, well, what do we want here? All we want is Japan sales greater than or equal to our average Japan sales. Now, this right here is what perfectly highlights just how powerful PsychoPG2 and integrating Python into SQL really is. We just did some really complex computation, and then we were able to insert this into our query. Doing this in SQL would have taken ages, but instead, because we already have this written out, it takes us one line. So we went from doing one line of SQL into like 22 lines of Python. We converted that like really inefficient use of Python into writing like tens of, or like, you know, like 50 plus lines of SQL into just one line of Python. So now you should hopefully see just how powerful that is by doing complex calculations and then inputting that into our conditions. So anyway, we have our res, and all we could do is just print our results. So if we do this, conditions, sorry, this should be conditions equals. So now we have quite a few video games that have high average Japanese sales. So if you remember, it was 4.65 was our average Japanese sales, and this is 6.81, 10.22, so 4.7. That's cutting a little close. But yeah, essentially we now have a bunch of video games that have higher than average Japanese sales. So we could now analyze these video games particularly and see like what are they doing wrong or what are they doing right, and that'll be something that will like really impress my fake so-called marketing team director or whatever. So with that being said, oh, actually, I love this game, Monster Hunter Freedom 3. I probably spent well over like 500 hours playing that on the PSP. Anyway, so now that we have a really complex query builder and we have ability to write really complex computations, SQL comes at a breeze. We no longer have to write SQL. We could just use our framework that we created here. That'll save us dozens of hours in like work time. And it was only really like 25 max lines of code, but we were able to do a lot of things that we would normally have to do repeatedly, like time and time again. The last thing that I want to show is another step of like modularizing our code. So if you see like there's kind of 3 steps. There's connecting to a database, there's your SQL stuff, and then there's like closing communication. I can even make this a little bit simpler and make this into a function. So we can define a function called like connect. And in here, we just do exactly this. But we don't want to hard code anything. So for the DB name, what if I want to use a different database, right? We could do DB name equals here VG sales. So the default DB name is going to be VG sales, but I could change that whenever I want. Same thing with user, and same thing with password. So now in here, I could just create a formatted string. By now, we should be really comfortable using formatted strings. And plug in our variables here. So password. And then we just return a connection and a cursor. So then here, connect to database. We would just do connection cur equals connect. And then same thing with closing communication. So def close on cur, we just do this. And then here, we just do close on cur. OK, so essentially what we have here is we went from writing about, 38, 37 lines of code, and we condensed it into like at most 6 lines of code. So hopefully that gives you a really great idea now of what I meant when I said automating your time using Python and being as efficient as possible in abstracting all these really complex SQL concepts into really easy to read, easy to understand Python code. So that is all I have in terms of the demo. So now I'm going to go back to the slides. Before we go, I just want to announce upcoming events. I don't know if Bhakti or Ashwarya or Nadi want to speak on this. If you do, feel free, or I could just go over it. But yeah, we do have our KPMG networking night. That is going to be the 10th from 6 to 7:30. So you guys can RSVP. You can find the links for the RSVP on our Instagram. Also, we have our web scraping workshop on Tuesday from 6 to 7 p.m. That is going to be a continuation of our accelerator program. So feel free to go to that.
I'm just going to jump in for the KPMG networking night. Personally, I actually did an internship at KPMG last summer. And I must say that a lot of the networking events were part of the reason, like I think why I got that internship. because I got a lot of FaceTime with the recruiter and I got to know a lot of professionals. So if you're, looking for an internship for your junior year, you're interested in KPMG, definitely would highly recommend coming out to our event tomorrow night. You'll get more one-on-one time with the professionals, and they'll basically remember you, help you out with the recruiting process, and how to stand out.
Awesome, thank you. And we also have our speaker series that are coming up. So if you're interested in that, take a read. We have one on Thursday, February 18th, with a data scientist that is really into like natural language processing and machine learning. So that is really cool, stuff like chatbots and sentiment analysis, which I find really, really interesting. And another one on Monday, February 15th. So this one is chief architect at Oracle for blockchain, which I find really cool because I just lost a bunch of money on Bitcoin earlier today. So I'd be really into that. But yeah, other than that, thank you guys.